Hey, this is Mr. Peterson with the first screencast for AP Environmental Science. Welcome to APES. Let me point out a few things about this course before we get started. The screencast you're watching now is how I teach most of the introductory material for this course. You need to take your own notes while you watch and listen. Add your notes from reading the book. That's not optional. The screencasts cover the majority of the material, but for an AP level class, you need to be listening to what I have to say and blending it together with your textbook, articles we read, reputable websites, and other resources. Just listening to the screencast might get you enough to pass the information on the test, but making A's and B's, or 4s and 5s on the AP exam, comes from reading and digesting multiple streams of information to get you all the way to where you want to be. Reading the book is a must and should be the minimum amount you read in this class. Let it also be said now that the screencasts are a function of maximum efficiency. To make sure you get through all the material as fast as possible, I may be reading my notes faster than you can take yours. The good news is you can pause, go back, and even listen again. Taking your notes ahead of time allows me to get into large discussions in class on the harder issues of environmental science. But you need to have a grounding in the basics before you can discuss the harder issues and come off sounding intelligent. That being said, I expect that about 80% of the information in this course you could pick up on your own by reading a few textbooks. Most of that is what the screencast is about. The other 20% of the information you need to learn will take a lot longer to practice and polish to perfection, and that's what we end up spending most of our time on in class. So I expect you to get the basics by watching this and reading the book, but that's really just the beginning of the understanding. I'll always answer your questions in this material, and I'll always ask some of mine to get you to a higher understanding beyond just reading the book. Now, if you're looking at a chapter outline, I use that outline to make my notes to go over the screencast. You get to use your notes on almost everything you do in class except for tests and essays. Taking note isn't understanding material, but it is a step along that path. It's taking the material you hear and read and boiling it down into a smaller form that's easy to review later. Details are important, but overall understanding is also there too. When you go back to study for, let's say, a 9-week exam or the AP exam later in the year, you have forgotten a lot of these details. This is proof that once upon a time you did know it and that it's just simple review that you're doing. For that reason, I recommend taking notes by hand, which is much more convincing to your brain that you did the work and is much more likely that you know and memorize what you need to know. Now, moving on into the actual lesson, we're going to spend the entire year learning about the environment. The environment is everything around us, from the ground under our feet to the air above our heads and everything in between. Environmental science is the study of how humans interact with the environment. And it really is a summary science and involves details from lots of different fields of science like the one shown here. Environmental science is still a science in that it relies on experiments and evidence for most of the information, and most of that comes from the parts shaded in blue here. But it also draws in information from fields like economics, political science, and ethics, because decisions have to be made about what to do in the environment. And while pure science has right and wrong answers, those fields shaded light blue-green deal in information that is more up for debate. And two different answers to an environmental problem can be equally correct. Now, we shouldn't get environmental science confused with environmentalism. Environmental activism, like these people from Greenpeace, is more political and social, and is concerned with protecting the earth, regardless of the cost. For example, these guys appear to be targeting fishing vessels, and by constantly harassing the larger ships, they prevent them from fishing as much. And that does, in some ways, protect the fish. Environmental science is concerned with protecting fish supplies as well, but what it does take into account is the fact that we have to have jobs, and we have to have useful work in order to keep our standard of living high. And it also, in all things environmental, it compromises to make sure that we achieve the greater good. Now, one thing about these screencasts is that they go along with the outline. If you check the first outline of this unit, I've been over the first 3 items already. If I put it on their outline, it's important to know. You can find more supporting details in your book, but you need to have some notes on your own paper to help remember what each idea is about and why it's important. However, don't expect me to pause in the screencast and tell you what I'm about to talk about. Make sure you read the outline ahead of time. By doing so, you'll be able to get the most out of these screencasts. A major idea in environmental science is the idea of sustainability. It's an old idea, seen here in the quote from the Great Binding Law. Sustainability is the ability of the Earth to support life and adapt to changing conditions indefinitely. The Earth's sustainability is supported by 2 major factors: natural capital and solar capital. Natural capital includes natural resources like water, plants, coal, and oil. Some of those natural resources are renewable, some of them aren't. Natural capital also includes natural services that the earth provides, like purifying the air and water and recycling nutrients from dead organisms back into the soil for new organisms to use. Solar capital, on the other hand, is inexhaustible in human timescales. Energy from the sun supports all life on Earth, and even in the non-renewable fossil fuels we have, like coal and oil, were originally solar energy. You can think of fossil fuels as batteries that were originally charged by the sun, but they aren't rechargeable. The sun provides energy to drive photosynthesis and also provides most of the renewable forms of energy like solar power, wind, and water power. If you think about it, wind and water happen because the sun heats the earth, causing wind and rain, and those are both harnessed to use a renewable forms of power. It's important to realize that many forms of natural capital are being used faster than they can replace themselves, and that degrades the natural capital to the point where it can no longer provide long-term sustainability for Earth. This picture of loggers is probably from a little more than 100 years ago, but you don't find trees like this in the forest anymore. If we use them up faster than they can be replaced and regrown, eventually we'll run out of these resources. Environmental science is partly about finding long-term solutions that allow us to use various types of natural capital to help us live better lives, but in a sustainable way that provides future generations as well. Eventually, all of society will have to become environmentally sustainable, because if we don't, there won't be any more environment, and then there won't be any more society. In a very real sense, you can think of natural capital as being like that old saying, but in this case, money does grow on trees. Environmentally sustainable societies meet the current and future needs of their people by using the resources around themselves in a way that does not compromise the ability of future generations to meet their needs. We can cut down trees today to make lumber and paper, and that provides jobs, incomes, paper, and houses for people. And as long as we don't use up those trees faster than we can grow them back, then it's environmentally sustainable for the long term. Environmental science is an intersection between science and many other fields, and one of them is economics. Countries are ranked as being developed or developing, and there are several measurements that are used to sort them out. GDP, or gross domestic product, is a measure of the total amount of goods and services produced in a country. Per capita GDP is related, and is determined by taking the GDP and dividing it by the total population of the country. In other words, if two countries had the exact same GDP, but country A had twice as many people living in its country than country B, country A would have a lower GDP than country B. On the picture here, darker shades of blue indicate higher gross domestic product. So, based on the GDP, countries can be ranked as developed or developing. Developed countries have very high per capita GDP, while developing countries have low per capita GDPs, sometimes even declining GDPs. Less than 20% of the world's population lives in developed countries, and if you look at these graphs, you can see some inequalities the two types of countries have. The bottom two are particularly important: resource use and pollution. Developed countries are responsible for both. A goal of the world is to improve everyone's standard of living to be like the developed countries. But if that's going to result in more countries that pollute like the developed ones do, environmental science is going to be a hot topic for a long time as we continue to increase the amount of pollution. Now, moving on. Let's get a few more ideas. Resources are anything obtained from the environment to meet human needs and wants. Conservation is the management of those resources in a way that minimizes waste and sustains the supplies of those resources for future generations. There are several types of resources. And the first one is perpetual resources. Perpetual resources are never, ever going to run out. An example would be energy provided by the sun. The sun provides us with useful energy, and it will one day run out of energy, but that's 6 billion years from now, and in human terms, it's a perpetual resource, because if the sun runs out, there is no Earth with life. Compare that to renewable resources, which can replenish themselves naturally if they aren't used up faster than nature can replace them. Fish are an example of renewable resources, because there is a sustainable yield or amount that can be harvested per year without impacting the resource's ability to regenerate itself. Environmental degradation occurs when the yield is exceeded, and instead of being maintained at a constant or increasing level, the level of a particular resource actually declines over time. Now, a big idea in environmental science is called the tragedy of the commons. In short, many of our environmental problems are global in nature because they involve resources that belong to everyone. Resources that belong to everyone are referred to as commons. In the case of fish, many fisheries are located so far offshore that they're effectively outside of the reach of a country's laws. The orange shaded areas around Australia are protected in various ways by Australian law. But outside of that, it's open season, 24/7, 365 when catching fish. There are many examples of the tragedy of the commons throughout the environmental science, but in short, if no one in particular owns a resource, then the general trend is to overexploit it until it's degraded beyond use. No fisherman has ever paid extra for leaving part of the ship's hold empty to save some for next year. Instead, it's a game of get everything you can while it's still there. Last up for resources types is non-renewable, like coal, oil, and metal ore. Technically, they are renewable, but the timescale of millions of years that's required for a geological process to renew them means that at a human timescale, they're non-renewable. Faced with declining stocks of these, the only solution we have are to reduce our use of them by finding alternatives, reuse objects made of them, and recycle objects made from them to make new things. Now, as I mentioned earlier, most people in developing countries would like to raise their standard of living to match that of developed countries. Along with that comes a problem. People in developed countries have bigger ecological footprints. Ecological footprints, shown in the top right, are a measure of how much land and water we needed to supply an area with every resource they need, but also how much it is to absorb and process the waste and pollution that is generated from using these resources. The problem right now is that the world's global ecological footprint is larger than the Earth's capacity to supply those resources. In monetary terms, it's like spending more money than you take. It's a deficit. The problem becomes worse when you consider that developed countries of the world have much, much larger ecological footprints than those in developing countries. Looking at the two families in the picture shown, with all of the possessions, it's not hard to see why. The family from South Asia probably meets the majority of the needs from their own land. The family from the U.S., though, has a much larger ecological footprint because they consume so many more resources. Again, the real problem is that the ecological footprint deficit isn't sustainable in the long term. So as developing countries move up towards being developed, all countries of the world will have to reduce their ecological footprints. There isn't any real option. Now, one related idea is per capita ecological footprint. Imagine that two countries have the same exact ecological footprint. They use the same amount of resources and everything. However, the first country only has 100 people in it, while the second country has 100 million people. They both have the same overall ecological footprint, but they have very different per capita footprints. Per capita is a term that means per person or unit of population. So the smaller population has a higher per capita footprint because each person is using a lot more of each resource than each person in the larger population. Per capita is an idea that shows up a lot in APES because it helps compare things across populations and from different sizes. Moving on, pollution is another major problem that we face in the world. Simply put, pollution is anything in the environment that is harmful to the health, survival, or activities of humans and other organisms. Pollution can be natural, like the smoke released from a wildfire, or they can be man-made, like the exhaust from burning gasoline. There are two classifications for pollution sources. The first one is point source, seen here. Point source pollution comes from a single identifiable source. This pipe dumping wastewater into a lake qualifies because it's easy to see where the pollution is coming from. Point source pollution is usually somewhat easier to deal with because if you can fix a problem right there, then it's done. Contrast that with the other kind. Non-point source pollution. You can see the difference here. The oil and gasoline that makes this rainwater runoff have an oily sheen to it came from a parking lot. Thousands of cars parked in and around the parking lot over the past few weeks and even months leave leaking oil and fluids from their cars. Those leaks built up in the pavement, and then when it rained, the water washed all of it down the drain. From there, it's washed into the rivers and oceans. This qualifies as non-point source pollution because it's very hard to identify exactly which cars and what area of the parking lot this pollution came from. There are gray areas between point and non-point, but like all things, it's good to have a place to start in order to work out your understanding. There's another way to categorize pollution, and it's on the basis of whether bacteria and other decomposers can break it down. This food waste is biodegradable because as long as decomposers have oxygen to decompose it and enough time, they will get the job done. All of it will eventually break down back into molecules and atoms and be recycled into new materials naturally. Everyone knows that food waste is biodegradable, but many other forms of pollution are also biodegradable. There are billions of species of decomposers, so there are many types of pollution that can be degraded into simpler forms naturally. It's another gray area because some things biodegrade quickly, like this food waste, might take a few weeks to fully break down, whereas some things, like a piece of waste lumber, may take several years to fully degrade. At the other end of the spectrum, for materials that there are no decomposers for, or that take so long to decompose, we have non-degradable pollution. Most of the trash in this picture is made of plastic that was dumped into the ocean and eventually washed up here. It could sit here for 10 years, and UV radiation from the sun would cause some of it to become brittle and break into smaller pieces, but it would still be plastic because it's non-degradable. Now, the effects of pollution are numerous, but we can put into three categories. First up, they can disrupt life support systems for life on Earth. Second, they can damage plants and animals, including us, and property. Last, they can just be a nuisance like this beach that has been ruined unless someone comes and picks all of it up. There are two major strategies for dealing with pollution, and they're pretty easy to understand. Pollution cleanup involves fixing the problem after it's happened, like picking up the trash and disposing of it properly. Pollution prevention involves fixing the problem before it happens or preventing it. Generally speaking, it's a whole lot easier and cheaper to engage in pollution prevention than it is pollution cleanup. So, why do we have environmental problems in the world, and why are we going to spend the whole year learning about them? Well, there's 5 major reasons, and the first one is population growth. Simply put, the world's population has grown rapidly over the past 200 years, and so many of the problems that we have now and face in the future simply weren't problems when the world's population was smaller because we didn't use as many resources as an entire population. But because the population is so much larger now and continues to grow exponentially, more people means more resources used. Next up, we are using many resources in an unsustainable way. This is a coal mine, one of many non-renewable resources on Earth, but this category also includes overuse of many of the renewable resources. Poverty is the third major reason we face environmental problems on Earth, and this one is difficult to grapple with. More than half of the world's population attempts to get by on less than $2 a day. For a person in poverty, their entire life is centered around getting enough food, water, and shelter to survive. That means that every decision they make is focused on the very short-term future. Faced with a decision to cut down the last acre of trees in a forest to have fuel to cook food for a family, or leaving the trees standing because they're important for absorbing carbon dioxide and providing shade to lower local temperatures, it's a no-brainer. Severe needs like that will always trump the long-term better choice, and it's hard to find fault with that. Fourth on the list is that the way our economies work, people don't pay for the environmental cost of their decisions when they pay for the market price for goods. For many years, lead-containing substances were used in gasoline as an additive to make engines last longer and run more efficiently. When people paid for their gas, they paid for the cost of the gasoline, the cost of the lead additive, the cost of the gas station to pay the attendants, and so on. However, the price people paid per gallon didn't account for the rise in brain damage and other neurological disorders in children living in the areas where they inhaled lead from car exhaust. Those costs were called hidden costs because we all pay them, but they aren't included in the market price and people paid at the gas pump. Seriously, if the cost of dealing with those problems were factored into the price of gas back then, gas would have been an unaffordable luxury. Thankfully, in the 1970s, lead was banned in gasoline because of the growing problems and replaced with less toxic alternatives. In short, we just don't see many of the costs of our activities and choices. They're effectively hidden when we don't pay for them directly. Last up for the reasons for environmental problems is the lack of sufficient knowledge. We know a lot about the way the world works, but on a global scale, there are many things that we just don't understand yet. And many of our decisions and activities take decades before the full effects can be seen in the environment. Now, last up, I will continually come back to the idea of sustainability this year. Environmental science isn't about environmentalism. People have needs, and part of life is about enjoying things while we're here. So the central idea is that we have to meet our needs here and now in a way that allows future generations to do the same without compromise. The best way to do that is to model our lives after natural systems, because life on Earth has been here for a very long time and weathered many, many changes. First up, we need to rely on solar energy primarily. All non-renewable sources of energy will eventually be depleted, leaving us with solar energy. That doesn't mean solar panels for everyone. Wind and water power ultimately drive their energy from the solar, and biomass energy comes from burning waste plant materials that grew from the sun's energy. So, we've got to focus on solar-derived power for the future, including wind and solar panels. Second, biodiversity is crucially important. The Earth is constantly changing place, and all of the species that live on Earth provide us with countless services that we cannot duplicate with all of the money and technology in the world. Protecting the Earth's biodiversity is like guarding a huge toolbox. We may not need some of the species in that toolbox today, but they represent the solution for human survival in the long term. It would be foolish for a mechanic to toss tools out of his toolbox simply because he didn't need them that day. Third up is population control. Natural populations are controlled by natural systems. Simply put, if any species becomes too numerous, it can become very attractive as food for another species, or they can decline because there aren't enough resources to go around for all members of the population. Human populations aren't going to be controlled by predators, but recognizing that we fit into those natural systems as well and that the Earth has limited capacity to support life should guide some decisions we face. And last, nutrient cycling has kept the Earth's matter in a constant loop of reuse for billions of years. If we want to fit into the long-term picture of Earth, we can use those materials that the Earth provides. But we need to focus on wasting very little of it and returning those materials to Earth so that the long-term cycling can continue and we can continue to be part of it. Now, one last thing. APES can and sometimes feel like full of doom and gloom, and that all these serious issues are just going to doom us. It feels strange to say in science, but have faith. Humanity has survived many, many challenges and will continue to survive this one. That doesn't mean it's going to be easy and that we're going to not have any tough choices, but we'll save that for another time. For now, that's it for the screencast. Thanks for watching.